All right, so today's topic is from what broke to what changed. I'm Mike Beemer, product manager at Dynatrace. I'm also on the governance committee of Open Feature.
And I am Parth, a software engineer at DevCycle. And kind of let's paint the picture a little bit. It's 3:25 p.m., and I know that's the time right now, so this is totally intentional. A bit of a kind of context to this. Anybody part of like a big organization or a bigger team has probably seen something like this, where you certainly get a message on your dashboard that just says failure rate increased to like X%, and whatever the affected service is. And now you start your investigation. It's 3:25. Now let's take a step forward. Like a little bit later, you're seeing there are no recent deployments that could have affected this. And then you're going to take some more time, investigate a little bit more. It's 4 or 5 now. You're seeing that there's no code changes in the last 48 hours that could have affected the services as well. Stepping more into it, it's now like 4:50. You're trying to track down what the cause is for this, figuring out what the problem could be. Everything looks healthy, dependencies, upstream providers. Everything is what should be expected. So as usual, what happens is all hands on deck, escalation, but now it's like almost 2 hours past. And everybody's kind of like finding every single way that this could have went wrong or is going wrong or what the issue is here. But then like at 6:25, so like 3 hours later, you figure, or somebody just says, oh, I toggled a feature flag. And that's the kind of root cause for everything. The main kind of point here being that feature flag changes are like invisible to our traditional monitoring. And that's what we want to talk a little bit more about. So how can we kind of make it so that feature flags are kind of part of observability and are not making our lives kind of harder to pinpoint themselves as the root cause? And that's kind of starts with the observability gap, where if you look at the current observability stack, you kind of see your error rates, latency, failed request, resource exhaustion, and like kind of the traditional metrics and traces. That's kind of what provides all these information. But what's mainly hidden is what flag got changed, who changed it, when was it changed, like who's affected, what variants are even being served. So all of the feature flag context is like very missing. If you look at a real world example of this, the OpenTelemetry demo that has been referenced, I think, a couple times today. So that's a great kind of place to look at. It's full of microservices, and it's set up as an e-commerce platform. There are multiple services, multiple languages, and production-grade observability stack for you to kind of like tinker around with. And already has open feature kind of built in. The main thing here is that it is the perfect test bed for how feature flags can enable like problems in production or anything. So one of the kind of problem scenarios that is recommendation service cache failure, which ends up being like a memory leak. And there's like some other more like specific to services or kind of how the loading process or anything works. And this is kind of trying to show what the impact versus root cause is. So your dashboards are all going to show the same thing, where it's like, oh, there is a response time spike from like 145 milliseconds to 600 milliseconds. But you don't really know what the cause is, where the actual cause of what's happening is a flag being changed. Somebody changed it from off to on. And that's the hidden truth behind this, is that it's a very quick fix of what should be the case. And it gives you the time to kind of actually debug properly. And I think in the talk above, where we saw that little spike and kind of panicking, taking a step back, and like kind of figuring out what that step to proper deployment was kind of a great example of that. But the monitoring tools do not have this connection at all. And that's where the kind of the problem that we kind of fall into is that we spend hours kind of restarting pods, rolling back code, debugging like kind of code paths that aren't even the actual cause for spikes that we're seeing, when in reality, you can just flip the toggle and get to like a stable state in your system, and then kind of know exactly what code path was the issue. And kind of going into why this matters is that we want to increase our MTTR, so mean time to recovery, and kind of slower recovery is kind of all kind of opposite of that. So that's that. Wrong direction, like when something breaks, everybody's going everywhere to just kind of find what the issue is. And the next thing is escalation. It becomes into an all-hands incident when it's not really like needed at that time. And because of this, we need feature flags to be like a first-class concept in observability. We're gonna go through like a leveling process of like how you can go from where you are today to kind of gaining the most amount of visibility into your feature flags, starting at level 0, which is flying blind. And this is kind of where we are right now, or mostly everybody is right now, where there's no visibility into flag changes. It's all guesswork if there's an incident, and hours spent just like kind of hunting down what the problem is. As you can see here, like nothing happening. And as we've kind of talked about this, I'm gonna go to level 1, which is that, like the reality is, as we've seen, like it's just a flag change. But level 1 is where we can kind of make sure those changes are coming to our services. An easiest way of that is like kind of broadcasting to every single service. So you can just be like, oh, flag change occurred on the provider, send it to our observability platform, every single service, because that's just easiest. But now this introduces another kind of problem in our flow, which is we don't know exactly if this flag is being used in the service, or if that's even the cause, or if this kind of change event coming in is becoming noisy for us even. So let's try to fix that a little bit. Kind of step into level 2, which is kind of manual change events, which what we mean by that is like kind of only sending the flag changes to the services that are actually using those flags. And when you have like microservice architecture, like this becomes very common where like you don't have flags being used everywhere. But this also has a problem. The problem here is manually like maintaining the mapping of everything, and it takes kind of few like different like engineers touching it, or maybe like a process miss in the flow to get this out of date. And like let's say if you're doing like a code refactor or like code cleanup, you can kind of miss the whole refactoring of this, and that kind of becomes out of sync, hard to manage at all times. And so let's get into a level 3, which is kind of automatic event mapping of this in some sorts. Now, we're looking specifically at a telemetry-driven routing, which eliminates the manual configuration. I'm not going to go into like how you would set this up, because there's so many ways to do this. But the goal here is you check your services. You can have your metrics of some sort going into like a detection usage, and that is what decides what services get the flag updates. And there are benefits to it. You have automatic discovery, very smart routing. There's no maintenance, and could be a good indicator, but you cannot know exactly what the impact here is. Like you don't know how many people it's affecting, what the actual, like if a flag is the cause or not, and if a variant is the cause or not. And this solves some problem, like scaling problem is easy to be solved. But it's a complicated setup of like, is this kind of something you want to do, and kind of how to upkeep it. And there are definitely ways to improve it further. So let's go more in depth of kind of level 4, which is trace level observability, which is what we want to refer to as the golden standard here. And this is where feature flags are your first class observability concept. This gives us very fine-grained insights. You can see flag evaluations because they're added into every trace. You can see real-time mapping of flag presence per service, because all you kind of have to do is like do a search and like filter the traces for a specific flag. And yeah, filtering by specific flags on requests is also a lot easier. You can compare variants, find the instant root cause. So let's see an example of like how this would look. Here's like a response time graph of all the services. And if you see after the flag toggle, there's like very noticeable change. If this was kind of your service, you'd probably be like, oh, there's not much happening. But when you slice this data into all of the request for flags, or with a specific flag evaluated, you will see that now there's a clear spike in services. Now it's like almost 10x of what we saw before. And so let's try to kind of slice this data even further and go per variant, where you have the control variant and you have the on variant. And you can see that on variant is clearly the root cause here. It's going from 160 milliseconds, and as an average, that kind of makes sense. But if you see like a very small kind of rollout, this becomes a very big issue. So kind of gives us the added insights into our variants as well. And that's kind of saying that trace level observability makes and allows feature flags to be our first-class citizens in our monitoring stack. I'm going to hand it over to Mike to talk a little bit about the standards now.
All right, yeah, thanks, Parth. Yeah, so just to kind of reiterate on that level 4, basically we're looking at a single service, and a lot of times in telemetry you would just see like those requests averages like just averaged out, right? So if you think about a feature flag, it may be for a specific route. Maybe that route is only hit with 5% of your traffic. You could really lose a lot in the noise. So that was really one of the big goals of getting into like trace level observability. Allows us to slice and dice that data a lot more granularly. So we'll dive into like how that actually works behind the scenes and kind of give you a glimpse of like our ideas for when we were like designing kind of the specification together with OTel. So a year and a half ago, I think we started with the OTel SIG. We have a dedicated feature flag SIG for how to define flag evaluations in OpenTelemetry. So obviously, open feature came from like the open standard feature flagging perspective and the vendor neutral SDKs. One thing that hasn't really been talked about much here today is there's a hook system in open feature, and the core idea was like we didn't want to burn dependencies into the SDKs. We wanted to give people the ability to add in custom functionality. Another interesting part of that is you can actually, if you're writing your own provider, you could register a provider hook. So this could be all abstracted from the end user, but it gives you the ability to do whatever kind of telemetry and debugging you'd like without requiring a dependency on the end user. And then OpenTelemetry, of course, is hitting from the observability perspective. The common signals are metrics, traces, and logs. They're adding new ones like entities and a bunch of other things, but we're basically tapping into the great work they've done. And another really interesting aspect is this semantic convention. So it's basically the idea of like every telemetry signal has these attributes on it. The attributes could be whatever that you want. It's just a string. So the semantic convention is basically a way to bring sense to that string. And that's also where we worked with them to basically define semantics around feature flags themselves. To really kind of drive that home, it's like the open feature SDK is there. We tap into the hook system. The hook system allows us to see each flag evaluation and basically like inject arbitrary code. In our case, we're just pulling out flag evaluations. We're sending it to OpenTelemetry, where you could go through OTLP or any other OpenTelemetry concept you want, and then pipe that information into the observability platform. So this is kind of funny. It's like it looks incredibly simple. In a lot of ways it is. It's like 6 months worth of debating on what these things should be called. I'll go through the obvious ones. So like basically the feature flag key, that one was pretty easy to get past as part of the spec. It's basically what you'd reference in code. It's the unique reference to what you'd have in your flag system. There's value and variant, which is kind of interesting. So we started with variant originally, which makes sense. It's basically like a user-friendly way of referring to the value. And that's really helpful, especially if you have kind of like obscure or maybe large values or JSON objects or whatever. But there's plenty of like providers that don't have variants, and so we just decided to also include the value itself. And so, yeah, you can basically choose which one makes the most sense for your use case. There's also like provider names. So I gave a couple examples like FlagD, Launch Darkly, and DevCycle. And the idea is to keep those short and consistent. So you'd want to have them consistent across all your technologies. If you have a Java SDK, it should be the DevCycle, and you wouldn't include Java on there. And then the result there. So that's a thing in Open Feature where we basically provide metadata around like the reason a flag was evaluated the way it was. And so that helps you basically say like, okay, you're getting this value because there was a targeting match or because it's a code default or whatever the case may be. Some of the more nuanced ones, so these are the ones that actually took probably the most time to define, is this flag set ID. And the idea is like we needed a way from telemetry to map it back to like where it's stored in the management system. So a lot of flag management systems will have something like a project or a namespace or something like that. And we wanted to have a way to be able to map back to that. I like to think of it kind of similar to like a ARN in Amazon, where it's like a user-friendly, unique identifier to map back to this location. Another one that's a little bit more nuanced is the feature flag context ID. And so the idea behind this one is this is the value that you'd usually use in like your hashing algorithm to distribute, like kind of pseudo-randomly distribute your requests. And you can use that basically to replay the state of the flag at that time and see like what percentage or what bucket this request would fall into. And then finally is version. And the version could be like a hash, or it could be a number, or whatever you want. Some way to basically say like, this was the rule set evaluated at the time. So with a lot of this, you can basically essentially replay history and see what the user saw at any given time. How it works, so this is just standard open feature. You're basically just registering a provider. It could be any provider you'd like. You register the hook. So this could either be done by the developer, or it could be done automatically as part of the provider. And then you just evaluate the feature flag. Once you run that, this is just an example of a trace. You can basically see it in your tracing system. And once it's in your tracing system, you can slice and dice requests however you see fit. And then basically why standards matter. So like because we've defined it in OTel, if everyone follows the standard, you can just basically use it. There's interoperability between different vendors and providers and tools. Hopefully there's consistency if people kind of understand the meaning and intent behind this. There's no like kind of nuances there. And then adoption. Hopefully, if it's something in the industry aligns on and we all keep going, it's just easier to adopt. And I think it's become fairly clear through a lot of these presentations that like this is kind of a pain point. If you don't have observability into your feature flag, it can be challenging, especially at scale. So again, really like the core idea between open feature and OpenTelemetry is we can start with like any provider. You could even have like your homemade system. You go through open feature, you use the OpenTelemetry hooks, and you can send it to basically any observability backend you'd like. And then I kind of want to take a next step in like progressive delivery. This has been a theme, I think, through the day. And the idea is like, we want to gradually expose customers to new features. We want to monitor the impact at each stage. We want to instantly roll back if there's a problem. And really the whole goal is to like minimize risk and maximize confidence. So like, this is basically an example of what it would look like. You roll it out, you do your deployment, and basically the feature is off. So 0% or like a dark launch is what it's called sometimes. You may enable it for 1% of users, monitor for issues. You could have it go for a day, a week, or 5 minutes, whatever you're really comfortable with as part of this rollout strategy. Progressively enable it to 10% of users, possibly like certain cohorts, like people that have opted in to being early access customers. Again, you monitor it, roll back if anything goes wrong. Maybe 50%, you do a 50% rollout, you keep that there for a week, and then finally a full release. This is just a quick example. This is from DevCycle, just showing like the UI for how you could maybe do a stage rollout. And in this case, this is going every couple days. We're just progressively rolling it out to a bigger percentage of users. And then just to really drive it home. So this is just a hypothetical, but we have this new checkout flow. It's enabled for 1% of users. It all looks good. Everything's green. If we keep rolling it out, 10%, still all healthy. Everything looks good. If we roll it up to 50, all of a sudden, maybe this load was the magic number, and all of a sudden, we're having high failure rates and latencies through the roof, whatever. We're detecting it, and then if we roll back, everything's back to normal. So I do want to reiterate, like this, we did affect real users here. Like that's just the reality. Like we were rolling out software in production, but because we did it progressively, we detected it with like minimal impact that possible, and then rolled back almost immediately. So the key benefits, like basically without this type of insights, you would have been essentially blind to it. You may have seen that spike in failure rate, but if it was for 100% of users, you would have affected, 50% more than we just had in our example. You may not have been able to detect the root cause. You may have seen the spike and reverted, and then spent the next week like looking through your code to figure out what in the world's going on. You couldn't, compare variants. So like in the case that we looked at earlier, like we could slice and dice that data and say the on variant has this trace and it has this exception every time. It's quite a bit easier to troubleshoot. And then, yeah, we basically had a high-risk deployment. So those are the big bang releases that you're trying to avoid. With observability, we're getting a lot closer to this like data-driven rollout. The instant issue and really the automated rollbacks are the big ones. It's like you couldn't do that in a kind of a traditional CI system where you got to wait 15 minutes for a new pod to spin up or something. And then you're just lowering deployment risk. You're not eliminating it, you're just lowering it. And then really, I think observability is kind of key to this whole progressive delivery story. Just quickly wanted to cover some challenges and opportunities here. So it's not perfect yet. It's a thing that we're still working through. So I was actually working with a customer last week, and you could argue they're using feature flags wrong, but they were actually making over 4,000 flag evaluations per request, which can get quite expensive on a telemetry tool when each flag evaluation is captured separately. So there are opportunities that we'll have to look at for like deduplication, sampling, and some kind of aggregation strategies. It also will require the provider to supply that additional context in order to really properly slice and dice it. Like we'll get the basics like a flag key, but I think to really get the value, you'll need things like the flag set ID and other things like that. Some of the opportunities ahead. So if this is interesting to you, we've only spec'd out the flag evaluations so far. And so if you're interested in helping us define metrics or defining the change event, so from a flag management system, what would it look like as every time you change a flag, what should the structure of that event look like? And then finally, this is a fairly new concept in OTel, but they're looking at entities and entity relationship models. So how could we represent a feature flag as an entity and define those relationships to services and apps? So yeah, I just want to encourage you, like I said, this is a work in progress. So we'd like to work with you to build together. Feature flags are powerful, it's basically essential to the modern developer workflow, but they need to be visible in our observability stack. OpenFeature and OpenTelemetry make this possible through the standards that we're defining. And we want to transform how you understand and deploy software, really from what broke to what changed. Thank you very much.